Hi, welcome. This is the first of 4 tutorials on transformations. This first one is about translations. Before we talk about translations, though, we should talk a little bit about what a transformation is. Transformation is basically a change in an object's size, orientation, or its location. And when we're talking about size, we're talking about how small or big something is. So if I do this to this blue box, I'm changing its size. Notice I'm keeping it, the shape is the same, I'm just making it either bigger or smaller. So it's like zooming it in or out. Orientation is I'm actually changing the position, but not necessarily the location, okay? If you look at what I'm doing right now, okay, I'm kind of flipping it, I'm reflecting it, I'm rotating it, okay? I'm keeping the center in the exact same spot, but I am changing its orientation. So orientation is a change that way. And we'll talk more about how you do these things as we go through the different transformations. And the last one here is location. Location is simply moving it from one part of an area to another part. Okay, notice I'm not changing the orientation, I'm not changing the size. I'm literally just moving it from one place to another. Okay, that's the one we're going to talk about first, this location, and that's called a translation. So a translation, once again, is basically a slide. It's changing the location of an object without changing its size or its orientation. So if we talk about translations in terms of functions, we can actually do something to the function to make it move to a different area, slide it to a different position or a different location without changing its size or its orientation. So if we look at this one, our parent graph is y equals x squared, and the parent graph of that is a parabola, and we know that's a quadratic function. So if I add 2 to the back here, notice what it does, okay? It moves the function up 2. Okay, let's see that again. So if I add 4 to the back, notice it goes up 1, 2, 3, 4. If I add 5 to the back, it goes up 5. All right, so that's a translation. It moved it up north 5 positions when I put in the 5. So what do you think will happen if I put a minus in back? Let's take a look. So if I put minus 3, notice what it does. It translated 3 south. So it moved it 3 south. If I minus 2, it translates it 2 south. So adding 2 to the back makes it go up 2 from the origin. Subtracting 2 makes it go down 2 from the origin. Okay? So that's 2 of 4 translations that are possible, going up north or down south. Now, so we talked about going north and south. We have 2 other directions, of course, we can go. We can go east or we can go west. Now notice I switched the graph to an absolute value graph just to show you that this is going to work no matter whether we use absolute value or quadratic or whatever kind of function we use. They're all going to work pretty much the same. So you can see with the absolute value, if I add 2, it brings it up 2. Right? Okay, so how do I make it go east? All right, well, if I want to make it go east, let's see. If I put it on the outside, we know that makes it go north. So what if I go inside the absolute value? And let's start with subtracting. Let's say I subtracted 3. What do you notice? It moves 3 to the east, 3 to the right. Okay. Now, one way of thinking about it, why does it move to the right when we put a negative in? One way to wrap your mind about this a little bit is, remember, the blue right now is our parent graph. The kid, all right, wants to get away from the parent. The red one is the kid, right? So what's he doing? He's moving away from the parent. What does the parent want to do? The parent wants to pull him back home, okay? So this kid is right now 3 to the east. How does it pull it back home? Well, it has to pull it in the negative direction, okay? So to get it back home, it has to subtract 3, okay? So if I subtract 3, it goes back home, all right? All right. Now, if I were to add 3, notice what happens. It goes to the left. So if we add a number inside the function, it moves to the left. If we subtract a number inside the function, it moves to the right. And we know right, once again, we're moving east. Okay? If we move left, we're moving west. So east over here, going positive, west going negative. All right. So those are our 4 possible translations. Now we can put them together and do 2 translations at the same time. So for instance, if I said +1, what does that do? That moves it west 1. Okay. And if I add a +4 to it, it also moves it up. So it moved 4 up and it moved 1 to the west. And notice, guys, the vertex tells you exactly how it moved. Okay, 1 to the west, and negative is west, right? So 1 to the west and 4 up. X values, Y values. X controls left and right, Y controls up and down. So this is 1 west, 4 north. Let's look at another one. So if I change this and I write it as, let's say, -2 and -3, how's that going to move it? All right, well, the negative tells me that we're going to move 2 east and we're going to move 3 south. And you can see where the vertex is. That's exactly what happened. We moved 2 east, 3 south. That's 2 to the right and 3 down. So our vertex is located at the exact spot where that movement happens. And remember, the movement's happening to the entire graph. But if we focus on the vertex, it really tells you how the whole thing's moving. All right? Let's try one more. And what the heck, let's use a different function. We're going to use our square function. All right, so we're going to change this to our square function. And it works the exact same way. If I put that x, and let's put a -6 inside there, notice what it does to the graph. Okay, it moves the graph 6 to the east. If I add a 2 in the back, it moves it 6 to the east and 2 up, because that in the back makes it go up or down, and inside the parentheses makes it go left or right. Okay, so where's that vertex located? It's located at point 6, 2. 6 because it moved it 6 east, 2 because it moved it 2 north. And if you notice something interesting about the vertex, no matter what this number is on the end, it's going to be the same number in the vertex, right? The y, if it goes up, the y goes up. If the y goes down, the y goes down here. Okay, but notice what happens with the x value. If this is a -6, the vertex is going to show it as a +6. If it's a +6, what happens to the vertex? Now it's on the west side, right? So it's a -6. So that's another way to look at it. If it's inside the parentheses, or the ones that control the left and right movement, if it's +6 here or plus any number here, it's going to be a negative in the vertex. If it's a minus in the vertex, it's going to be a plus in the vertex if it's the minus in the parentheses. So that the x values kind of work the opposite of what you'd expect. Okay, and that's always the case no matter what function we're talking about.